Practice Problem Chapter 9. The spotlight effect refers to overestimating the extent to which others notice your appearance or behavior, especially when you commit a social faux pas. Effectively, you feel as if you are suddenly standing in a spotlight with everyone looking. In one demonstration of this phenomenon, Gilovich, Medvik, and Savitsky asked college students to put on a Barry Manilow t-shirt that fellow students had previously judged to be embarrassing. The participants were then led into a room in which other students were already participating in an experiment. After a few minutes, the participant was led back out of the room and was allowed to remove the t-shirt. Later, each participant was asked to estimate how many people in the room had noticed the shirt. The individuals who were in the room were also asked whether they noticed the shirt. In the study, the participants significantly overestimated the actual number of people who had noticed. In a similar study, using a sample of 9 participants, the individuals who wore the t-shirt produced an average estimate of m equals 6.4 with a sum of square of 162. The average number who said they noticed was 3.1. The question is the estimate from the participants significantly different from the actual number? We want to test the null hypothesis that the true mean is 3.1 using a two-tailed test with an alpha of 0.05. As always, we start by what do we know? In step 1, we state our hypotheses. So the null is that participants do not differ in their estimate of the number who notice, so that means the population mean would be 3.1. And the research hypothesis is that participants do differ in their estimate of the number who notice, so that means the population mean would not be 3.1. In step 2, we're setting the critical region. We know we're supposed to use a two-tailed test with an alpha of 0.05. So we know in order to read our critical t from the table, we need the degree of freedom. If we have 9 people, that means the degree of freedom is 8. And for an alpha of 0.05 for a two-tailed test, again from the table, we see that the critical t is plus minus, because it's a two-tailed test, 2.306. Next we calculate our t. This is the t formula. Here I compare. Do I have everything? I have the mean, I have the population mean. What I do not have is the estimated standard error of the mean. So I know I need this formula. Write this formula down. Here I need the variance and the number of people. Again, the number of people I already have, but I do not have the variance. What I do have is the sum of square. And that's good because I know that's part of the variance formula. So now I just write the variance formula down. And here I see I have everything and I can plug it in. So I get a variance of 20.25. Now I take the variance, I can plug it in here. I get an estimated standard error of 1.5 that I can now plug in here. So I get a t of 2.2. Why I wanted the t is because I want to see if my mean difference, that is the basis for the t, is in the critical region. So I compare to my critical t over here. So I make a decision in step 4. And I can see that for these data, my t is 2.2. With a degree of freedom of 8, the critical value is 2.306. So that means my 2.2 is smaller than this. It's not in the critical area. So therefore, while the participants actually overestimated the number, because we can see it is different, right? The mean for our sample was different, a lot larger than the population mean, but it was not statistically significant. Therefore, we fail to reject the null hypothesis. And again, we're saying it's not statistically significant because this 2.2 over here that we figured out is not in the critical region because it's smaller than the 2.306. So it's in the hump and not in the tail. If you have any questions, email me anytime. I'm here to help.